Good day, everybody. Notice that we have a super large 5-digit modulus here along with 4-digit numbers here. Now again, you're a calculator away with a modulus button of solving this problem, but where's the fun in that? So we're trying to solve this without doing a big calculation. Okay. Now a big result here that's very simple to state arithmetically is m minus n is always going to be congruent to minus n itself mod m. All right, simple enough. Now what we're rooting for here is a single digit n. If we can get a single digit n, in other words, another way of saying this would be m is much greater. That's what I'm intended by these two greater than symbols here. M is much greater than n. In particular, we're rooting for an n with maybe with even a single digit. The reason being that minimizes your computation. Obviously, single digit multiplications aren't challenging, right? Aren't particularly challenging. Single digit, okay, single digit. Okay, so let's get busy on this problem. Now, the first big observation that is very related to this is that we're only, if you look at this, look how close 6 times this number, okay? 6 times this larger number, and it could have worked for either one, I guess, but we did 6 times this larger number gives us a number very close to the modulus. In fact, it's congruent to -5. Notice that 20,496 is congruent to -5 because that's the same as 20,496 plus 5, which is the modulus itself, right? So you see, we've made some progress already by getting close, getting a number that is close. This product is close to the modulus. Now, the way we benefit from that is just simply rewrite what we started with, 1824 times 3416, okay, is equal to the 1824 that we've written down. And then we rewrite 3416 as 20,496 over 6. But by the commutative property of multiplication, yes, there's a 1824 over 1. You can shift the, you can divide 1824 by 6 to get this, and the 20,496 is left standing, okay? Now, why is this super helpful? Well, what we get is this whole thing. And again, y'all, we're dealing in congruence mod 20,501, okay? So this would be congruent to 304 times -5. And wow, all of a sudden this is like we've died and gone to heaven, right? Because now we're just stuck with knowing what this is equal to and then reducing it modulo 20,501, which is fairly easy actually. So this is equal to minus what, 1520? Now, to get a number in the set that we're interested in, is that right? 5 times 304, yes, minus 1520. Okay. Now, to get a number that's less than 20,501 and greater than 0, all we have to do is add the modulus to this, okay? So this would be congruent to, if we add, now this calculation is a little hard. You have to do it by hand, I guess. But 20,501 minus 1520 is effectively what we need right here. And that would give us 18,981. Now I wrote that, it's a hand calculation I did. I'm not showing you the work there, but at least this hand calculation, just noting that 18,981 plus 1520 is the modulus, okay? And again, I'm checking it right now. 18,981. That looks like we got it. Looks like we got it going on, right, folks? 18,981. So that's what I'm getting is our answer. And notice that it is a proud member of this set right up here. And I'm not promising. There's always a chance I made a mistake. But the idea is what's important here. You start with these massive numbers, and then you nudge this one as close. You try to find a multiple of this one or this one actually that will be as close as possible to 20 8,501, hopefully you're getting in within one digit, which is what this worked out to be. Now, sometimes you're not going to be this lucky. And also notice that the 6 would have to be a divisor of 1824 for this to be effective. 1824 just happened to be divisible by 6, right? So this isn't always a guaranteed way of doing things, but it is always an approach to where you can minimize the magnitude and usually get to, I don't want to say usually, I don't know, but often you're going to get to single digits, maybe small double digits, okay, where it becomes a tractable hand calculation, okay? But anyway, I thought that was a fun problem, and I'm going to, let me just come back up here and put 18, what was it, 18,981? R is equal to 18,981. And notice we could ask, this is called the least positive residue, I think, something like that. We could pick any set here we wanted. You could do an infinite number of these type of problems by just adding multiples of the modulus to the least positive residue. Okay, straight from number theory. Okay, thanks for viewing.